Hello everyone. This is my channel Because Physics Matter, and today it's the first video I'm uploading for you. And in this video, I'm going to discuss the important things about units, measurements, and dimensions. So basically, there is a confusion always. What are units? What is the difference between all these three things? So we are learning the basic concept behind units, measurements, and dimensions. So what is the difference between units and base quantities? So the table says there are two columns, and you can understand we have one column units and the other column is base quantity. So if I'm saying that the weight is 3 kg, so that simply means kg is the unit, which simply means kilogram. And because right now we are talking about the mass, so that is the base quantity. So the mass is a base quantity. I will soon explain what are the base quantities in the next slides, but a unit is attached with the numerical value, so you can understand the things from this slide. So similarly, as you can understand the 60 second, so the second is a unit, and because the measurement in terms of second, this is actually for time, so time is the base quantity. Similarly, if you are measuring the things, measuring the distance, so that is in meter. Obviously it will be in kilometer or millimeters, like that, but right now we are talking about the base quantities, the general units. So the meter is the quantity, sorry, the meter is the unit, and with this meter a length is attached, because meter is giving you the information about length or distance, and so the length is the base quantity and meter is attached with the numerical value, which is actually a unit. Similarly, if we talk about the current, the electric current, so 9 ampere means the ampere is a unit, and because this thing is measuring the electric current, so this is the base quantity. The electric current is the base quantity. Now, I think you have understood what is unit. So unit is attached with the numerical value. So whenever you will see 5 kg, 3 second, 60 meter, so the word which is attached with the numerical value, that is the unit. Then what is the base quantity? So base quantity, as I said, that unit actually define the base quantity. So if I'm talking about 5 second, so here the base quantity will be, as in the previous video you have seen, the base quantity will be time, because second is giving you the information about the time. So we have base quantity also and we have units also, but we have only selected some base quantities, because even in the SI system, which I will soon tell you, in SI system we have only 7 base quantity. So here you can see there are few points which you must remember. The universally accepted standard for base quantity. So the base quantities are adopted in such a way so that it will be these are universally accepted. The second thing is limited number of base quantities are accepted. So as I told you that base quantities are limited in numbers. So according to SI system, we have 7 base quantities, and other physical quantities are defined in terms of base quantity. So we have time, mass, and other things, the distance, electric current, and thermodynamics, and other things. So we have these base quantities, and all the other quantities, because only 7 quantities cannot define everything. So all the other quantities are actually depends on the base quantities. So I will show you how. So the first question, when it was decided to define a unit, so that was to define a unit which is accepted by all and which can define every measurement from a very small one to the biggest one. So for example, let us suppose I want to define a unit for distance. So if I want to define a distance, so the first challenge initially was that the unit must be defined and accepted by all. By all means everyone will use the same unit, so there will be definitely there must be some standard. On the basis of that standard, the unit can be defined. And also the unit must be such so that even for a small distance or for a large distance, easily it can measure the particular quantity. So this is the important thing. International system of units, which is also known as SI units or metric system. So this was according to this unit, 7 quantities are adopted as base quantity. So 7 quantities are adopted as base quantity. Universally, these 7 quantities were adopted, and I will show you which quantities. So here you can see we have 7 base quantities which are accepted universally. So these are mass, time, length, electric current, light intensity, thermodynamic temperature, and quantity of substance. Okay, so now the question is that these are the base quantities, and accordingly we have units. So the unit of mass was defined as in kilogram. For time it was taken as second, for length meter, for electric current ampere, for light intensity candela, for thermodynamic temperature it is in Kelvin, and for quantity of substance it is in mole. So these are the 7 quantities which are accepted as the base quantity according to SI system of units. So for example, if we talk about meter, so meter is accepted for a distance measurement, and it is accepted as a light speed in vacuum, because we know light travels the distance very fast. So in vacuum it covers a distance of 1 meter in this small fraction of time, 1 by 299,792,458. So that is the fraction of second in which light covers 1 meter. So that was accepted as a unit for distance measurement. Similarly, the other units were accepted according to different standards. Now you know what are units, and you know what is the base quantity. So units are attached with the numerical value, and base quantities are actually the thing which a unit is giving you the information, and there are 7 base quantities according to the SI system of units. Now there is another term, that is the derived quantity. So as I said that there are only 7 quantities in SI system, then what about other thing? For example, I am talking about the distance. So for distance, I say I have taken a unit that is in meter, or I say that distance is taken as a base quantity. Then what about speed? Because speed is also a physical phenomena, and speed must also be decided by some units or some quantity. So there are other quantities which actually are dependent quantities, because if we talk about the speed, so we can say that the speed is the ratio of distance to time. So distance is a base quantity, time is also a base quantity, but speed is not considered as an individual base quantity. It is a dependent quantity which depends on the ratio of 2 base quantities, distance and time. So in that way we can say that these are the dependent quantities, and so we say that these are derived quantities. So now I think the concept must be clear. We have the base quantity, and we have the derived quantity. Base quantities are adopted according to the SI system. These are only 7 quantities which has been considered as base quantities, and all the other quantities are actually depends on these base quantities. So the other quantities are derived quantities. Now the important thing is unit conversion. So for example, if we have units, 1 unit, and we want to convert this thing to other unit. For example, according to the SI system, the second is given as a base quantity for time measurement. Now let us suppose I want to convert it in minutes. Okay, so these are some simple things. Many times you have to convert the units from one unit to other units. So for that, we simply use this very easy technique, that is a conversion factor. We simply multiply the unit with a conversion factor, and this conversion factor is important. So we say that we simply multiply the unit with a conversion factor, and this conversion factor, what is a conversion factor? It is a ratio of units that is equal to unity. Now this is important because if you multiply anything with something which is equal to 1, there will not be any change in that particular thing. For example, if I have a variable x and I am multiplying this x with 1, so there will not be any change in this x. So this is your conversion factor. Now this 1 is actually a ratio of unit that is equal to unity. I will tell you how. For example, if you want to convert 5 minutes to seconds, so now your unit is in minutes and you want to convert it in second, so what will you do? You simply multiply 5 minutes with a conversion factor. This conversion factor is actually, if you see, this is the ratio in which in the denominator the same unit must be there. So if minute is here, then minute must be in the denominator, and you know, in 1 minute there are 60 seconds. So in the above term there are 60 seconds, in the lower term in the denominator there is 1 minute, and so the ratio is equal to 1. So this is very simple technique. You will define the conversion factor in such a way so that the denominator term and this unit term, these two units must be same, so that they will be cancelled out, so that you can cancel this minute with this minute and your answer will be in second. So that will be 300 seconds. Okay, I will give you another example. Now let us suppose I want to convert the second into minute. I have 360 seconds and I want to convert it in minutes. So again, this is our original unit and I want to convert it into minutes. So now I have reversed this conversion factor. Again, this is 1 minute by 60 seconds, so the answer is 1. Okay, the value of this conversion factor will be 1 minute by 60 seconds, so this will be 1. But in the denominator you must take a unit which is the same as your original unit which you want to convert. So when you do that, this will be cancelled out, this second will be cancelled out with this second, and then your answer will be 360, and 60 is there, so you will divide it, so this will be 6 minutes. So in this way, this is very easy. You are taking a conversion factor which is actually 1, but inside this one you are writing the things in such a way so that your original unit which you want to convert, that will be cancelled out with the denominator unit, so these two must be same, and the above unit, then in the numerator term you should have the unit in which you want to convert. Another example is this. I want to convert this 500 meter to kilometer. So 500 meter is my original unit. Now I know that in 1 kilometer I have 1000 meter. So if I put 1 by 1000, the answer will be 1. So the conversion factor value is 1. Now you can see in the denominator I have meter. So the meter and meter will be cancelled out. And your answer will be 500 by 1000 kilometers. So that means 0.5 kilometer. So in this way, you can very easily convert the things from one unit to other unit. And this is very important. And if you understand the concept, then it will be helpful for you in all your future calculations. Now, the third thing which we are going to discuss in this video, that is dimensions. So as now you have understood what are units, you have understood what are the base quantity, and the third thing, what are the derived quantity. Now we are taking another thing, that is dimension. So in very simple terms, the definition, I just want to repeat this definition because this is very simple. A simple expression which shows the dependence of a quantity on base quantity. So you know that there are 7 base quantities, and we have the symbol of these base quantities also. For example, when I'm writing the dimension for mass, I'm using capital M. For time, I'm using capital T. So in the same way, I'm writing the things in dimensional formulas according to the base quantity. So that is the concept, a simple expression which shows the dependence of a quantity on base quantity. It is expressed as a product of power of symbol. So I just show you, because right now you can understand this is L to the power A, M to the power B, and T to the power C. But I have not told you anything about A, B, or C. I have not told you anything about that. So there may be a confusion, what is A, what is B, what is C. So these are the things which are coming from the general formulas of these quantity. But you need to understand, if you are writing the dimensional formula, then for length you will take capital L, for time you will take capital T, and in the same way for quantity of substance you can take capital N, for light intensity capital J, for mass capital M. So the question is how to write the things, how to write the dimensions, or how to calculate the dimensions. So this is very simple. For example, if I talk about speed, so speed, as you know, it is the ratio of the distance traveled upon time. Now we know that if I talk about the distance, so for distance, as I have shown you, for distance I will use L. Okay. Similarly, if I talk about the time, so in the denominator we have time. So the ratio will be, in dimensional formula you can write the things L by T. So obviously that simply is equal to L T minus 1. So that is the dimension of speed. That is so simple. So in that way you can very easily write the dimension. I will give you another example, acceleration. So now when I talk about the acceleration, this is simply change in speed upon time. Now you know the speed dimension is Lt minus 1. So that means in the speed dimension, the upper term will be the same, Lt minus 1, but in the denominator there will be time. So this you can simply calculate change in speed. So the speed dimension will be there upon time. So upon time is, I will write the time dimension. So that will be Lt minus 2. Okay, so that is simple. So in that way you can write the dimension. Similarly, if I'm talking about force, so force, you know, force is equal to mass into acceleration according to the law F is equal to ma, which is a very popular rule, F is equal to ma. So for mass I can write m, and for acceleration as discussed above I can write Lt minus 2. So the dimension of force will be mLt minus 2. So this is simple. Similarly, pressure. So for pressure I can write pressure is equal to force per unit area or force by area. So I have specially taken these quantities which are interrelated, For example, acceleration is related with speed, force is related with acceleration, pressure is related with force. So if I talk about force, so force we have calculated the dimension mlt minus 2. But if I talk about area, so area, there are in the area we have two things, length L into B. So the dimension will be L2, and so in the denominator I have L2. So in the numerator there is single L, so that will be L minus 1. So your dimension for pressure will be ml minus 1 T minus 2. And one more, that is momentum. So P is equal to m into V. So mass into the speed or velocity. So P is equal to m into V. So m, for m I'm writing this m as a dimension formula is telling you, and V, this we have calculated in the first one, LT minus 1. So your simple dimensional formula will be MLT minus 1. So now you have understood that these are very simple ways to write the dimensional formula, and these dimensions are very important. Right now I have taken only very simple quantity. Okay, but soon you will see that we have bigger dimensions also, like gravitational constant, which depends on some roots. So but in the same manner you can easily calculate. So in the coming video I will tell you about these things also. Now one more thing I want to discuss with you, that is the dimensionally consistent equations. So what is the meaning of that? The meaning is, in an equation dimension of each term must be same. So that is the thing, your equations must be dimensionally consistent, otherwise the equation is not correct. So that means you have to check the dimensions of the equations. So in an equation, dimensions of each term must be same. That is the first thing. The left hand side and right hand side must have the same dimensions. So that is also an important thing. The left hand side and right hand side must have the same dimensions. And now I will show you how can we say. For example, I have these three equations and you are well familiar about these three equations. So this is speed, this is also speed. So if I simply write the things here, so here you can see that this is a speed. We have just calculated that the dimension of this is LT minus 1, because the speed is this is the distance upon time. So this is LT minus 1. Similarly, the first term of this is also LT minus 1. But if I am talking about the second term, in the second term we have acceleration multiplied by time. So we have seen that acceleration dimension is LT minus 2, and if you multiply this acceleration dimension with time, which is T, your answer will be again LT minus 1. So now you can see all the terms are having the same dimensions, and the left hand side dimension is equal to right hand side dimension. So this is LT minus 1, this dimension is also LT minus 1, and this is also LT minus 1. So this equation is dimensionally consistent equation. Similarly, you can check for other equation also, like this S is the distance, so the dimension is simple L. Now if you simply calculate the dimension of U into T, U is, as you know, the speed, so the dimension is LT minus 1. So the dimension is LT minus 1, and if you multiply it with time, so time is T. So if you multiply LT minus 1 with T, your answer will be L. So again, the dimension of this first term is L, and this is also L. Similarly, A into T square. So A is the acceleration. So the dimension for acceleration is LT minus 2, and T square, that means the time. So this is T square. So again, that when you multiply these two things, you are going to get L. So this equation is again a dimensionally consistent equation. So this is a very important question. If you have some equation, you can check the dimension of all the terms, and you can find out whether the equation is possible or not, because if they are not matching, if the dimensional things is not satisfying, that there may be something wrong with the equation. So similarly, you can check for this also. This I just leave on you. The v is the speed, so lt minus 1 and the whole square. Similarly, this u is also lt minus 1 whole square. So obviously these two are same. But when I talk about this last a into s, so a is lt minus 2 acceleration and s is the distance l. So that again will be lt minus 1 square. So in that way, now you know that if you want to check the validity of an equation, the simple way is you just check the dimension of all the terms and also both the sides. If the dimensions are correct, that means the equation is valid. So now in this video we have learned few things. So I just summarize all the things. First thing is, what is the difference between units, base quantities, derived quantities and dimensions. So this I have explained to you. In the second important point, we have seen what are the SI unit system, how many base quantities are there according to SI unit system. Then how to convert the units from one unit to other type of unit, like kilometer to meter, second to millisecond, or some like same type of units you can convert. And then the dimensional analysis. So these are the important points of this video. If you like the things, then you can comment in the comment section. You can also like this channel. I will soon bring more interesting video for you. So till then, just enjoy and learn the physics.